Hello again. This is now Friday, 4/24/20. We're nearing the end of the year. You have received your quiz 7/8. The due date's there. It's on the following Monday. You can access it right now if you want. It's based on this chapter that we're doing. It's the last quiz of the year. You have worksheet for chapters 12 and 13, which is your homework. There is no web assigned for chapter 12, 13. And the project, you have received a long email from me. Please read that. That tells you everything you want to know from now till the end of the term. Okay? Now, today we're on section 12.3, and we're doing exponential integration, and this is we're still on the indefinite integral. Next week we get to the definite integral, which we only spend a few days on. Okay, so the rule for exponential integration is if you're trying to find y by integrating, and it's given as a e to the u f of x dx, all you have to do is define u, define a, define f of x, take the derivative of du with respect to x, plug in a e to the u f of x divided by du dx plus c. Now f of x could be a constant or it could be a polynomial function. Let's take this example first. Well, this starts with dy dx equals ex. So what I have to do is multiply both sides by dx. And that gives me that the integral, and now dy equals 5ey dx. To put the integral sign, now you can write this as 5e to the x 1 dx. This will be a function. Notice in this case, f of x is a constant. It's 1. Define for, you need this for the exponential rule. You need a, you need u, you need f of x, and you need du dx. So here a is 5, u is the power x, f of x is 1, and du dx is 1. Now you plug it into this rule here. Y equals a, 5, u equals x, f of x is 1, du dx is 1. Of course, they cancel. So the answer here is 5e to the x plus c, and that is your indefinite integral. If this was a practical problem, we'd need more information to solve c. Okay, let's do some other problems now. This rule is right over here. So all right, so let's take a second example. Okay, it's a pretty complicated example. I think I have a better one here. Yeah, okay, example 2. Start with this one. The integral of y is the integral of 2x e to the x squared dx. Now, notice the f of x can be either between here and here. I mean, in other words, I could write this if I want, e to the x squared 2x dx. Doesn't make any difference because this is the commutative rule. So you might find f of x here or between here and the dx. Still the same. So here we want to make a is 2, or you know what? I could leave the 2 out here and just make f of x equal x. That's probably better. Okay? So a equals 2. Double a equals 2. U is going to be the power. F of x is going to be x. This time it is a polynomial in the x to the first power. I need du dx, looking at my rule. And now I have everything. If I look at my rule up there, I have a, u, f of x, and du dx. So let me substitute. Substitute in the exponential integration rule. So y is going to equal to a, which is 2. It says e to the u is x squared. F of x is x. And du dx is 2x plus c. Notice the x's cancel. That's what I want to do if I had an x. Okay. Now the 2's will cancel too. So this is simply going to be e to the x squared plus c. Simple solution. This is it. Okay, now how would I check this? Let's suppose I want to check this. Well, I would take dy dx equals d dx of e to the x squared plus d dx of c. Derivative constant equals 0. This would be a chain rule where u would equal to x squared, and I haven't given this up there. And du dx would be 2x. So the derivative here, according to our rule here, would be a, which is 1. A is 1. E to the x squared returns, times du dx, which is 2x. And that's du dx. That's 2x e to the x squared. If I multiply it by dx, I get back what I have here. Okay, so that checks out. I mean, you don't have to check it. I wouldn't ask you to check it. But if it's a long one, I would actually check it just to make sure. All right, let's do another one. A little bit more difficult. Not much. So example 3. Now I have the integral of y equals the integral of x squared dx over e to the x raised to the third power. Now there's no quotient rule in integration. I always suggest if you have something in the denominator to bring it to the numerator. So I'm going to rearrange this.
Quick question, Dr. Mirabile.
Yes.
For completeness, on the left side, should it be integral of y dy?
Yeah, it should. Well, but that's not the way yeah, it should be, but I can also write this. Okay? That gets rid of the dy. The extra appendage. All right, so basically, I'm going to rearrange this. X squared. I'm going to bring this up. Now, the power gets negated, not the 3. The power here is x to the third. So it's going to be minus x to the third. Be careful. This is when people make their mistakes. This is a power raised to a power. I think they call this a Gumpert's function or something like that.
Not familiar.
Yeah, I forgot the name. Sounds like a some sort of cartoon. It's the Gumpert's brothers, brought to you again in living color. Their famous joke: I woke up this morning, I saw an elephant in my pajamas. What an elephant was doing in my pajamas, I'll never know. Anyway, so what do we do here? We're going to use our exponential rule, which means we have to start defining, it's right up there, a e to the u dx, which I have. So a is going to be 1 because there's a 1 outside here. We're going to make u equal, this time minus x to the third. F of x is what's attached there. Okay, and now I need du dx. It's going to be minus 3 x to the 3 minus 1 x squared. So now I have everything, so it's a simple plug-in. Plug into equation rule 1 there. So plug in to exponential integration rule. All right, so we have a, so y equals 1. It says e to the u, and u is minus x third. It says f of x, which is x squared, divided by du dx, which is minus 3x squared. What's the matter? Problem?
No, I'm good.
Oh. Okay, so dx squareds cancel. That's good. And you're going to have here y equals minus 1 over 3. Don't forget there's a negative here, and that's the denominator. E to the minus x third plus c.
I'm trying to remember if earlier I suggested it should have been integral y dy. It really should just be integral dy.
Yes, that's what it should be.
Either y or integral dy.
It should be integral dy
Yeah.
because that's what I had.
Yeah, if you had integral
on the
y
other
dy,
side,
it would
yeah,
be y squared over
because
2,
I just
yeah.
multiplied out by the dx. I'll show them next time what you're talking
No
about.
worries, yeah.
Okay, so basically, minus 1/3 e to the minus x third. Just don't forget, when you're bringing this up here, the power is x to the third, not... I've seen people bring this up here and have e to the x to the minus 3. That's not true. That's the power of the power in the... That's really... This exponent of e is x to the third. Okay, so just remember that. A lot of people have made mistakes on exams on that. Let's take another one. And our example would be 4. And I'm going to do, here's what Greg is talking about. I have dy dx equals 10 x minus 1 e x squared minus 2x dx. When I multiply out by both sides by dx, I get dy equals 10 x minus 1 e to the x squared minus 2x dx.
Yeah, actually, in the first equation, you have too many dx's. You should either get rid of it on the left.
Oh
or the
yeah,
right.
this isn't a dx, right? No, that was never there.
Right, there you go. So you start with the derivative dy.
So
dx.
now when I integrate, it's going to be the integral of dy, which is simply y.
Right.
Okay, so that's a lot better because you have your dy, when you multiply out by dx, but both sides, this is what I meant to do. That's why I put that there because I had the parentheses. That should be a dx.
Yeah, and then the bottom that equals y. Yeah.
And then that's dy, and the integral of dy is simply y. So to complete this is really theoretically sound way of doing this. I tend to take shortcuts, which is what you tend to do when you've done this a whole number of times. Okay, so let's erase this and try. This one looks really complicated. Wow. What am I going to do with this? Follow the rules. What do you need? A, U, F, X, and du dx. Here, you got to define these. Simply, A equals 10. There's your constant. Let U equal what? X squared minus 2x. That's the exponent now. So U equals x squared minus 2x. All right, what about f of x? F of x is this appendage here, x minus 1. Now I have a, I have u, I have f of x. I just need du dx. That's going to be 2x minus 2. Now I have everything that I need. It doesn't make any difference how complicated this is, as long as you let u equal the power of the exponent, and f of x equals the appendage, which is a polynomial or a constant. So now I'm just going to plug in the exponential integration rule. And here we go. So y is going to be equal to a, which is 10, e to the u, which is x squared minus 2x, f of x, x minus 1, divided by du dx, 2x minus 2, and add the c.
All right, we're at time.
Okay.